Hey guys, in this video we're going to learn how to graph linear equations in slope-intercept form. Alright, to actually graph a linear equation in slope-intercept form, we always had to change our equation so that the y is equal to the rest of the equation. So that whole process, when we're solving for y, the form, not necessarily in the right order, but there's this form that's called slope-intercept form. That's what we're doing today. So the slope-intercept form of a line, or the slope-intercept of a line for a linear equation is y equals mx plus b. So then the equation to the right, we ask ourselves, well, is this in slope-intercept form? Well, we have the y and we have a plus 1 equals 2x. Well, we need the y set equal to the rest of the equation. And we have a plus 1 on that right side, or I'm sorry, the left side of that equal sign with the 1 or with the y. So what we're going to have to do is we're going to have to subtract 1 from both sides, and that would zero out the 1's. And we're left with a y equals, and since 2x and negative 1 can't be combined because they're not like terms, 2x minus 1. So now we look at this equation and it's in the same form as slope-intercept form, and we can easily identify what our slope is, which is 2. So our rise is 2, our run is 1, and then our y-intercept is negative 1, which is our b in our equation. So b is equal to negative 1. So how we graph this line is that we start the y-intercept of negative 1. So the y-intercept is where the graph crosses the y-axis. And then we use our slope to rise 2, run 1. Rise 2, run 1. And notice how I'm putting a dot every time I run to the right. So I have rise 2, run 1, rise 2, run 1. And then as we start falling off the edge here, you can go in the opposite direction and go down 2, over 1 to the left. Put a point. Down 2, over 1 to the left. And then connect your lines. Connect your dots. This would be our graph of our linear equation of y equals 2x minus 1 in slope-intercept form. Alright, in example 1, let's practice identifying the slope and the y-intercept of a line with the two given equations. Alright, so let's focus on A. So A, for slope-intercept form, we need to be written y equals mx plus b. So if we look at this equation, we have y equals x plus 3. There is no m. However, what we have to keep on thinking is that if there is no coefficient in front of the variable x, there is an imaginary 1 there. So and then our y-intercept is 3, positive 3. So we know m equals 1 over 1, or 1, and then our y-intercept is just 3. Alright, in B, we have negative 2x plus y equals 5. Again, let's write down our slope-intercept form of a line. And now we ask ourselves, well, is this equation written in slope-intercept form? I think not. So we need y set equal to the rest of the equation. So what I'm going to do is I'm going to add 2x to both sides to get y all by itself. And since we cannot combine these two, we're going to zero out the 2x's. We have y equals 2x, since we know that the term mx, it needs to go first in slope-intercept form, plus our positive 5. So now we can easily identify what our slope is. M equals mx plus b, m equals 2 over 1, b equals 5. So our y-intercept where the graph crosses the y-axis is at 5, and then from there we rise 2, run 1. Rise 2, run 1. Alright, so in example 2, let's actually graph an equation using slope-intercept form, taking our equation 4x plus y equals 2. So we write down our slope-intercept form of a line and ask ourselves, is it written in that form? I think not again. So what we're going to have to do is get y by itself, so we're going to subtract 4x from both sides. Zero out the 4x, we have y equals negative 4x plus 2. And now we can easily identify what our slope is and what our y-intercept is. Our slope is at negative 4 over 1, and then our y-intercept is at positive 2. So we start graphing by putting a point at the positive 2 on the y-axis, and then we go down 4 because we have a negative 4, and we run 1 in the positive direction. Put a point. Once we put our point, we connect our dots, draw our arrows, and there's our graph of our line. In example 3, we have to identify what parallel lines are. Well, parallel lines are lines with the same exact slope. They can never, ever, 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 ever intersect. So looking at line A, B, and C, let's determine what the slope is using rise over run and figure out, well, which ones are parallel. So the graph or the picture can be kind of confusing, so we have line B right here, line A right there, and line C. So let's find the slope of each. So again, parallel means same exact slope. So we're going to go from this point on line B and rise all the way up to the same level as the other point that we're looking at. And so we've actually moved up 6 units. So our rise is 6 and our run's going to be 6. So the slope of line B is 1, which is made from 6 over 6. And line A, we're going to rise 6 from this point. And we're going to try to go to this point, so we have to go up 6 to get to that same level. And we're going to run 6. So then right away, our slope of line A is 6 over 6, which is simplified into 1. And let's check C, and that we from this point to the left on line C, we're going to rise to the other point given to us. We're going to rise 7, and we're going to run 9. So the slope of line C is 7 over 9. So if you look at all three slopes, which ones are actually the same? Line B and line A. So the slopes of line B and line A are the same, so we say that line B is parallel to line A. I don't know why I clicked so fast. Alright, guys, thanks for watching. Make sure you do watch or write down any questions that you have. Sorry about the interruption from the announcements, but that's how things go when you record live. Alright, have a good day, guys.